Take 7. This is not going as well as I planned on it. So in this video lecture for MIET 392 underground mining, what I wanted to discuss was sort of my thought process for when I'm presented a problem like this, like we're doing for the class project, right? And kind of the first thing I think of when I see a map and I know there's going to be multiple seam stuff, the first thing I'm going to be asking myself is, number one, where are the gob areas? Because, and we'll go over this in a lot more detail in the rock mechanics class, but gob areas tend to be de-stressed from the vertical stress field because you've extracted this, you've allowed it to cave. That gob does not necessarily fully compact, like, for example, around the edge of the panel. So you would have sort of very low stress right at the edge, and then as you go towards the middle, that stress will increase and then dissipate back towards the other edge. If you have a panel that is critical or supercritical, meaning that its width is greater than or equal to the overburden depth, then you have a case where at the center of the panel you will see the vertical stress return to the in situ level, so the same level it was prior to mining. And then as that panel width gets wider, you would see a trough there. So it won't exceed that stress, but it can get back up to it. But in this case, these are basically subcritical panels, except maybe, over here on the edge somewhere. No, this is going to be subcritical regardless, given its depth of cover. But so to me, I would be looking for those areas, and then I would also be looking at the pillars themselves and the underlying seam. What's their condition? Are they stable? Are they a critical size? Have they already failed? That sort of thing. So I figured one of the better ways that we could introduce using ACPS for cold pillar stability analysis is to just take a look at what we have here. So to get ACPS, if you don't have it already, you're going to go back to minegroundcontrol.com. Remember the website we've been getting several of our softwares from already. You're going to hover over ground control and click on cold pillar stability. Bear with me, the internet is quite slow here. There we go. You can scroll down, you can read about all the updates that they've had. You can download a paper on it, also a presentation that was made, the help file you can download, and of course you can download the program here. I already have it downloaded, but if you click that button, it'll download again, and you can install it there. So with that, let's open up ACPS and perhaps get started here. The first thing that we can look at is the underlying set of mains in this area, and only the center lines are shown, but these mains are driven on 80 by 120 foot centers. That's fairly large, but these are fairly deep, right? So it's 200 feet deeper than our extraction level. So in that case, it's roughly around 1,200 feet of cover. So if we go to ACPS, we can see what the stability factor of those pillars are. We'll make sure, this is usually already on development room of pillar, or maybe it's the last one thing that you did, but make sure development room of pillar is selected here in the input project description tab, development room of pillar, and I'll be using feet and pounds, imperial units, as opposed to metric. You could put a title in here, underlying mains. Oh, I spelled that wrong. That's why I don't usually do a title. There we go. So put that in if you want. Next form. So our entry height. Entry heights in the underlying seam, we're going to assume 6 feet. Depth of cover, 1200. And some more information on the depth of cover. You can do like a weighted, or not a weighted average, but a simple average. If you take the maximum overburden, which occurs here and maybe here as well, and you look 200 feet on either side of that line or that point, you can come maybe back to back here and somewhere around in here, right? But you can clearly see that, we're in this sort of 1,000-foot, maybe 1,050 feet at our seam level, which again we have to add 200 feet onto. So that sort of average, if it's 1,200, we can even say 1,250 here. The entry width is the standard 20 feet for this area. Although you can cut that down to 19 or 18 if you need to for either roof support or something like that. Those were 8 entries, and the pillar width was 80 feet center to center, and the spacing is equal. Crosscut spacing was 120. Okay, so we can view the plan, and it looks correct. And we can actually see the results here. 2.54 is the stability factor for the mains, except there's one thing we didn't really take into account. Now it's shallower here. Okay. It's between 900 and 1,000 feet, so 950 feet plus 200, 1150. In this area, we will need to select retreat mining because we want to take into account the fact that these pillars are extracted here. There's gob here and abutment stress on these pillars. So we have an active section and a side gob. And for our active gob, there's no retreat mining in here, so it's 0. The side gob, just put something larger than the depth of cover in here because it goes on forever. And sort of I explained with the subcritical, supercritical panel width. Once it's mined beyond that sort of 1,200 feet of cover, in this case 1,150, you won't see any additional stress. So just put it past there, and then the barrier pillar, we're going to have to probably use the composite barrier spreadsheet, but just as a first look. Let's just say that it's 120 feet. So this is 100 foot or 120 foot center pillar. So the pillar itself is 100 feet. So let's just say that's 200 feet for the barrier. And then we look at our results. And our safety factor went up. Did it? No, it didn't. Oh, that's right, because we changed the depth of cover, right? Because it's a little bit lower over here. Okay, good. Glad I caught that. So with the retreat mining, it does reduce the safety factor some, but it's still well above 1.5. It's above 2. My thoughts on this, would automatically just be that these pillars in the mains they're stable. And then if we look to the first panel, which is driven on the same size centers, okay, same roughly, depth of cover. We can say that I want to say it's 1,000 feet and not 1,000 feet. I'm going to say it's 1,200 feet and not 1,250 because, this is kind of the area we'd be looking at, and it's between 900 and 1,000. So I'm saying 1,200 feet here. So we can go put that back in again at the depth of cover, 1,200 feet. The barrier here is 100 feet wide. Okay. And that's rib to rib, not centers, which I know is a little bit confusing. But so we have one active section with no gob. There's been no retreat mining in this panel. Our side gob width we will take into account accurately this time, and it is the width of this panel, which is 660 feet. And then they said that barrier once again was 100 feet, except there is a row left in the side gob, right? And that row is half this pillar width, so it's 30 feet wide. 80-foot centers, 20-foot wide opening. It's 30 feet wide. Now, we can check the results on that. And our stability factor is above a 2 for those pillars, and the barrier is above a 1.5. It's a 1.92. So that's looking to me to be relatively stable. Now, what about this panel? Now, it was successfully extracted. Okay, so they did okay while they were mining it. And we want to see right here at this line, at the deepest possible cover, what the safety factor is. And so our depth of cover ranges from 900 to 1,000 feet on our level. That's once again 1150, 200 feet below us, right? 1150. The pillars were sized the same, 80 by 120, and 20 entry width. Okay, so for the retreat parameters, now though, we do have an active gob. And you can even put in like the real number for this, and it's close to 3,000 feet or so. We do still have row A, right? But we're also, for our first side gob, there is no side gob here, right, in this panel, because these pillars are split over here, they're intact over here. There's no clear indication that there's full extraction mining around this. So for the time being, first side gob is 0. That barrier pillar is 100 feet once again. I'm going to take that back. The barrier is 130, and there's a 30-foot slab cut taken out of it, right? So when they were mining back, they started slabbing this barrier as they went. We can check that on the plan to make sure that looks good. 30 feet, yes. Pillar sizing is good. We need to take that out. There's not a half row left here. There is a row left here, but it's not a full row, so you can only do a half row. It's okay anyways. That pillar crushes out. So let's look at the results. Our retreat mining pillar stability factor is 1.64. That is better than 1.5, so that would have been stable when they mined it. It's probably still stable now. You'll find out when you mine it, right? But most likely, I would consider this to be stable currently, right? Currently stable. The barriers look good, but let's think about one more thing. Let's just go ahead and just assume all of this is collapsed over here. Let's see if we did put gob over on that side, what that might look like, and we still have significant barrier pillar safety factors, stability factors, 1.6 almost on our pillar stability factor. There is a warning here that you need to conduct regular burst hazard assessments if you're deeper than 1,000 feet. We will talk about that as well when I go over the roof control handbook. Some of that's in there, and then I can also show you some, potential mapping for that, but that's just a warning that comes at any time you're over 1,000 feet with rim and pillar mining. This pops up. Like I said, our pillars appear to be stable, even if these over here are not. Okay, so that leads us to this panel, the last one. And let's see. Yeah, we hit 900 feet of cover here, 1,000 feet here. Once again, that kind of maximum is about, I don't know, about 950. So our depth of cover, 1150 is pretty good for this one. Now, these pillars, like I mentioned in the sort of overview, these pillars were split on retreat. Okay, and by that I mean they were mined into from the center, from near the center of the opening at an angle into the pillar. And just split kind of like that. Almost like it's like a partial pillar, like your Christmas tree, just a little bit as you come back, um, instead of full extraction, and you can leave that sort of open. And so the pillars are split, and that means that our crosscut spacing is cut in half. Okay, so now we actually have pillars that are wider than they are long, but we don't have, we do still need the retreat mining tab because we have retreat mining adjacent to us. So our active gob with our length is going to be 0. And our first side gob is 660 feet. And the barrier is 100. Okay. Results. Okay, so our barrier is nice and stable, 2.0. However, our pillars now are a 1.36. So if you remember when we first discussed, using ACPS or ALPS or ARMS high wall miner, what I mentioned was that sort of the design guideline, the stability criteria has historically been determined, based on a 90% chance of success based on all of the case histories that are in this database sort of behind it, right? But here we have a 1.36, okay, not a 1.5. And so we have this pillar that may be critically sized. We're not sure. We're not sure about the current status of the stability of these pillars. Depending on how long, they existed, they may not, they may already be, kind of crushed out. But on the other hand, these very well could still be stable for now, right? There's still probably a 50% chance or so. So we will have to, keep that in mind when you are using ACPS for the active seam that we will be designing, our mine for. Okay, so we've looked at everything. I'm just going to discard all of this. We've looked at using ACPS to determine the pillar stability of the underlying workings of our project mine. We determined that the mains are most likely stable. First panel is most likely stable. The second panel was retreat mined successfully, and it does not appear that there was any additional failure out towards the mouth of the panel. Those pillars still meet the stability factor criteria. So it's relatively unlikely that those are damaged, that they've been crushed out or something like that. This panel, however, where the pillars have been split, is not like that. And in fact, those pillars could be critically sized. We're not sure if they are intact currently or not. One way to perhaps get an idea prior to mining, if they are, is to drill this, core drill it, and look at the core above the seam. A lot of times in mines, particularly, for example, the overlying workings in this mine, we'll go ahead and turn those on for just a moment. A lot of these areas have over time collapsed, particularly when they were widened out like this. So you drill these, and what you see is in the strata overlying the coal seam, you'll see that it's fractured and broken. And so that can be an indicator that the pillars underneath you have indeed, failed and crushed out. But without that, we'll discuss how to tackle this one in an upcoming episode, just so that this doesn't get too long. But so for now, that's a good example of using ACPS in sort of a variety of different scenarios. We can, also, use it for, we'll also be using it for the active seam, as you lay out those panels. So with that, I'm going to close this out, and we'll see you next time.